What if life wasn't just possible, but inevitable, wherever the conditions were even remotely right? What if evolution found a way, no matter how strange, to fill every ecological niche? Welcome to Kepler 442b, a world where the familiar rules of Earth may not apply. Our mission: to use real science to imagine what life could truly be like on this tantalizing exoplanet. Kepler 442b orbits a K-type main sequence star, Kepler 442, significantly cooler and less massive than our Sun. This means the planet receives less energy overall, and the light that does reach the surface is shifted towards the red end of the spectrum. Kepler 442b is a super-Earth, estimated to be about twice the mass of Earth and roughly 1.3 times its radius. This gives it a surface gravity of approximately 1.17 g. That means you'd feel slightly heavier than you do here. While we can't directly analyze Kepler 442b's atmosphere yet, models suggest it likely has a denser atmosphere than Earth, perhaps with a higher concentration of greenhouse gases like carbon dioxide. This would be necessary to trap enough heat from its dimmer star. The big question is, does it have liquid water? Kepler 442b lies within the optimistic habitable zone of its star, meaning liquid water is plausible. Scientists estimate an equilibrium temperature of -40 degrees Celsius, making a greenhouse effect very important for the planet to be habitable. Given the planet's size and the likelihood of volcanic activity, a carbon dioxide-rich atmosphere is a strong possibility. One major uncertainty is the planet's axial tilt and rotation. We don't know if Kepler 442b experiences seasons like Earth, or if it's tidally locked, with one side permanently facing its star. Now let's imagine life on Kepler 442b, shaped by these conditions. Due to the red-shifted light from the K-type star, photosynthesis on Kepler 442b has evolved in unique ways. The Umbraflora, or shadow plants, are massive, tree-like organisms with dark, almost black foliage. To efficiently absorb the available red light, they've maximized their surface area and developed pigments optimized for that specific wavelength. These large herbivores are adapted to the 1.17 g gravity. The ground strider has 6 legs with broad padded feet to distribute its weight. The legs provide stability and prevent sinking into the soft forest floor. The atmosphere of Kepler 442b is denser than Earth's, allowing for easier flight. The Glimmerwing is a small, flying creature with large, iridescent wings. The dense atmosphere provides more lift, and the iridescent wings scatter the dim light, creating shimmering displays. Living beneath the Umbraflora, the root burrower is a pale, worm-like creature that feeds on decaying plant matter. It is blind, navigating through the soil using sensitive chemoreceptors. A predator adapted to the dim light of the Umbraflora forest, the shadow stalker is a stealth hunter with excellent low-light vision. Its dark coloration provides camouflage, and its large eyes gather as much light as possible. Living on the forest floor of Kepler 442b are the Lumiflora, a species of fungus that glows with a faint blue light. The Lumiflora has adapted to use the detritus and the shadows created by the trees to grow. As dusk settles over the Umbraflora forest, the ground striders gather near a stream, their heavy bodies casting long shadows. The shadow stalker lunges, But the calf's mother intervenes, using her massive body to shield her young. The shadow stalker, outmatched, retreats back into the darkness. Meanwhile, beneath the forest floor, the root burrowers continue their tireless work, enriching the soil with their castings. The Lumiflora glow brighter, attracting insects that help spread their spores. The cycle of life continues on Kepler 442b, a testament to the power of evolution to adapt to even the most challenging environments. From the dim red light to the slightly higher gravity and dense atmosphere, every aspect of Kepler 442b has shaped the life we've imagined. This is a world where the familiar rules of Earth don't necessarily apply, but where life, in its own unique way, has found a way to thrive. Given the denser atmosphere and slightly higher gravity, what other forms of locomotion do you think could evolve on Kepler 442b?